apply De Morgan's law using Venn diagrams. So you're probably thinking, what is De Morgan's law? Well, let's remember. De Morgan's law tells us that A and B complement. So the complement of A and B equals the complement of A or the complement of B. Now, I want to show you this on this particular diagram. Okay. Now, first let's focus on the left side, A and B complement. Well, what is A and B? Well, if you look at this, A and B is the shared space. So A and B is just space 2. So that means A and B complement is literally everything else. It's all of this on the outside of that. So that means it's 1, it's 3, and it's 4. Don't forget about the piece out with the universal set. Okay, so the left side of De Morgan's law is sections 1, 3, and 4. Great. Okay, so now let's talk about A complement. Well, we know that A is just section 1 and 2, right? That's A. So that means A complement is 3 and 4. Because remember, the idea of complement is everything else. So that means if I want B, well, B is 2 or 3. So that means B complement is 1 and 4. So if we're looking on the right side at A complement or B complement, that's 1, that's 3, and then they share 4. Notice 1, 3, and 4. So we can use that, right? That idea that A and B complement equals A complement or B complement. Okay, now that I've showed, let's do a problem. Let the universal set be -2, 0, 1, 4, 8, 12, 13, 14, and 19. Let set A be -2, 1, 12, 14, 19. Let B equal 0, 1, 4, 12, 19. You use De Morgan's law and a Venn diagram to find A complement or B complement. Okay, first, let's draw this Venn diagram because, that will be helpful. So, draw my rectangle. Here's my universal set. I have A and B as circles that overlap. First things first, what do A and B share? I always like to start with the shared space. So I see that they both have a 1. They don't share a 4, they share a 12, and they share a 19. So that goes in the shared space of A and B. Okay, what is left in set A? I've got a -2, I've got a 14. In B, I have a 0 and a 4. Now it's important to go through the universal set to see what we have left that goes on the outside. So we have -2, 0, 1, 4, 8. 8 is going to be on the outside because it is not an A or B. I have 12, 13. 13 is going to be on the outside. 14, 19 already taken care of. Okay, so I have my Venn diagram set up. Now, we know, based off De Morgan's law, that A complement or B complement is the same as A and B complement. Okay, what is A and B? Again, A and B is the black, inside the black shaded region, right? 1, 12, and 19 is A and B. So the complement of that is literally everything else. So A and B complement is going to be -2, 0, 4, 8, 13, and 14. I just put them in numerical order, but it's -2, 14, 0, 4, 8, and 13. So it makes it a whole lot easier to do the A and B complement, right? To say, okay, if I know A and B, it's just everything else is the complement. Then going through one by one and saying, okay, what is the complement of A? What is the complement of B? And then finding the OR. So we can do the things a lot easier using De Morgan's law just to make things simpler, right? Less or fewer steps, less likely to make a mistake doing it that way if you take fewer steps. But mathematically, you would get the same answer.